thing with the unit conversions is one, you don't have to write down the unit conversions because they'll always be provided before the problem. You just need to know how to work with it. So for our first one, if we're asked to convert 4 feet to inches, you find the unit conversion that relates feet and inches. So looking at these, here we've got this one. 12 inches is 1 foot. Okay. And now you ask yourself, we are starting at feet. So focus here. Now, what happens if you start at feet and you go to inches? You started at 1 and you ended up with 12. Do we agree we got larger? And that answers the question, should I multiply or divide by 12? If you get larger, then you should multiply. So we're going to take the 4, we'll multiply by 12, and we'll get that's equivalent to 48 inches. So always you're going to be multiplying or dividing, and you multiply if the direction you're going makes you larger, you divide if the direction you're going makes you smaller. So for instance here, inches to yards is this factor, and we're starting at inches. We're at 36 inches, and notice in the conversion factor, if you go to yards, you were at 36, and then you became 1, so we got smaller. That means we have to divide. So I should divide my number by the conversion factor of 36. So I'll take 72, divide it by 36, and we would get 2 yards exactly. Now I'll leave these. Whenever I post these solutions, you can work through the remaining 2 if you'd like. You could write them down: 4 miles to feet, 7 yards to feet. We also dealt with the metric system. Let's go over 2 of these, and then I do have one more announcement. Here we're starting at meters, and we want to go to decameters. Now, whenever you go up, you need to divide by how many movements of a power of 10. If you go down, you multiply by powers of 10. So to go from a meter to a decameter, we go up 1, which means I'm going to take those 100 meters and I'm going to divide by 10 once, and I'll get 10 decameters. But if I'm going through the reverse, if I'm starting at decameters and I want to go to decimeters, notice I have to move down twice, which means I have to multiply by 10 2 times. So down, multiply by 10, up, divide by 10. So I'll say 3 times 10 times 10, and 3 decameters is 300 decimeters.
So we see the different conversion factors for weight given above. Let's take a little bit of time and work through these examples. I want to give everybody a few minutes to attempt these on their own, and then we'll discuss the work together. So hopefully you've had some time to work on these problems. Now let's get started. We see the first one is 48 ounces to pounds. So again, the idea is to find the correct conversion factor. Looking here, we see that there's 16 ounces in a pound. Now there's many ways that people like to structure their work for these problems. I'll illustrate one possible way. We're starting with 48 ounces. I want to turn ounces into pounds. I know there's 16 ounces in 1 pound, rewriting my conversion factor. And as I show my work in this way, the ounces will cancel, and I know what's on the bottom I need to divide by. So we'll get 48 divided by 16 times 1 is itself, exactly 3 pounds is the equivalent weight in ounces. So now for the next one, 4,500 pounds to tons, we look for the correct conversion factor, and we see there's 2,000 pounds in 1 ton. So we can solve if we have 4,500 pounds, and we know there's 2,000 pounds in 1 ton. The pounds will cancel, and we'll be able to figure this out if we take our 4,500 and divide it by 2,000. And we get exactly 2.25 tons. Now our next one, pounds to kilograms. As we work through this, I see the third conversion factor listed will be related here. 2.2 pounds to kilograms. So as we work through the problem, we start with 22 pounds. We know that for every 2.2 pounds, we've got 1 kilogram. The pounds will cancel, and this tells us I should take the 22 divided by the 2.2 and multiply by 1. And we'll get exactly 10 kilograms. Now our last one is just metric system to metric system, grams to centigrams, and we know within the metric system there's a particular pattern of whether you're going up the chart or down the chart. So let's find our two things. If I'm starting at grams, that's here, and then I want to go to centigrams, that's here. So I see I'll actually need to go down the chart twice. Now keep in mind, every time you go down the chart, it's multiplying by a factor of 10. So as I've gone down the chart twice, this takes 20, multiplies it by 10 for the first move down the list, multiplies it by another 10 for the second move down the list. So that'll get me 20 times 100, or 2,000 centigrams. So for the metric system, remember when you go down the list, you multiply by 10. And if instead you went up the list, you would divide by 10. Now our last topic from this section is temperature, specifically going between Fahrenheit and Celsius. We're asked to go between 32 degrees Fahrenheit to its equivalent value in Celsius and 60 degrees Celsius to its equivalent value in Fahrenheit. So if y'all would attempt these problems on your own, after you've worked on it on your own, we will discuss it briefly. So in our first one, we focus on the fact that we're starting with Fahrenheit. So we're going to use this problem, or this formula. It says, give me the Fahrenheit value, subtract 32 from it, and then multiply it by 5/9 and you'll get the Celsius value. So as we write this out, this is our Celsius value is 5/9 times my Fahrenheit value of 32 minus 32. Now 32 minus 32 is 0. 5/9 times 0. If you type this in your calculator, you'll get 0. So 0 degrees Celsius is the same as 32 degrees Fahrenheit. In the next example, we start with a degree Celsius and we're asked to find Fahrenheit, so we'll use the first formula. It says take whatever Celsius value you have, for us it will be 60, multiply it by 9/5, then add 32 to that. So that would be 9/5 times 60 plus 32 and we get exactly 140 degrees Fahrenheit is the equivalent value to 60 degrees Celsius.